All right, so now we want to look into section 3.2, which is getting information from graphs. So in this next two sections, 3.2 and 3.3, we are going to be looking at getting points from graphs, determining if graphs are graphs of functions, getting domain and range from graphs, talking about increasing, decreasing. So lots of little topics that we can get from the graph. And I realize that, this is often an uncomfortable subject for most people. So just try to do your best, to focus on what you're actually looking for. So the first bit of information we can get from a graph is whether the graph is that of a function or not. And the way we do that is from the vertical line test. So if a vertical line intersects a graph more than once, then the graph is not a function. And that just implies that you've repeated x values. So on these examples here, we want to determine if each graph below is the graph of a function or not. And in this first one, it is, because there's no way I can draw a vertical line anywhere and intersect this graph more than one time. So this is a function. Part B is the same thing. I can draw vertical lines all day, and I only cross it one time with each line. So this one also is a function. But if we look at the third one, I can draw a vertical line, I intersect it in two locations, so that one would not be a function. So, that's some information. It's not something we're going to be quizzed on a lot, but that is some information you can get from a graph. The next one are, function values. We can also find function values. We can find domain and range. We can find lots of information from looking at the graph. So if you look at the graph, that we're given there, we can see lots of information here. One, we've got a point, -1, 1, right here. We go left 1, up 1, that's that point. We got a point here, 0, 3. Now, this one is not identified, but it's still a point on the graph. So one thing you've got to be conscious of is that you're not always looking for specific points that are plotted. There's lots of points. These are all points all the way through here. We got a point here, 4, 0, 2, -3, so on and so forth. Okay, so just because they're not plotted with dots does not mean there's points here. I mean, there's a point here. Okay, I mean, it's kind of hard to identify, but it would be like, 3/4 and 1. So don't forget there's points everywhere along these curves and these lines. Now, the one thing we can look at is the domain. And if you look at the domain, remember it's the set of all x values. And you can see the domain goes from here to here. These are all our x values. And the way we would write that is my domain goes from -1 and it goes to 5. Now, with this hollow circle here, that means that we leave the parentheses open-ended. We do not list the -1, 0, 1, 2, 3, 4, and 5 because there are points between -1 and 0, 0, 1, so on and so forth. I mean, this graph is continuous. If it was just points plotted, that's different. Now, the range, which we've talked about as well, is your set of y values. And that goes from here up to here. So it's the lowest point on the graph to the highest point on the graph. Doesn't mean that it has to be on the y-axis. And my lowest y is -3. My highest y happens to be +3, and those are both brackets because those points are shaded. Okay, so you can find function values, you can find domain and range, and again, always remember that y means the same as your f of x. It's just different notation. Okay, so let's look at an example here. We've got this graph right here. It has two endpoints, so it is continuous all the way through, no breaks in it. And we want to use the graph above to provide the following information. So I want to find f of 0. So remember, the number inside the parentheses is your x. So if I wanted to find f of 0, well, that means x is 0, y is 3. So f of 0 is 3. If I wanted to find f of negative 4, I go to negative 4 on the x-axis, locate the graph, and that equals 2. F of 2, go to 2 on the x-axis, and that's 0. Okay, so if we're given the x, we can find the y. The domain. So again, remember, your domain goes along your x-axis, and it looks like our domain starts here at negative 4, goes all the way through to positive 4. So it is negative 4 to positive 4. My range, set of y values, so I look for the smallest y, which is 0, highest y, which is 3. So my range is 0 to 3. And keep in mind, always list the smaller number first. Intercepts. We've got two x-intercepts, one y-intercept. So my intercepts are negative 2, 0, 0, 3, and 2, 0. So far, it's been fairly straightforward as to what points we're looking for, domain and range. It's not always that straightforward, but this is hopefully so you can get the hang of what you're looking for. Part E, we want to know how often does the line y equal 1 intersect the graph. Well, here's where y is 1. So if I draw this line, and I don't want to mess up the graph right now because I'm going to mess it up here shortly, but if I look at it, it would cross 1, 2, 3, 4 times. Now, usually for most people, these first 4 or 5 items, are okay. I mean, sometimes there is some confusion with domain and range. Once we get here to F and G, that's where it tends to get a little difficult. So, look at how F reads. For what values of x does f of x equals 2? So what this means is, if y is 2, what is x? That's how we translate that. So, in this instance, I go to 2 on the y-axis, and we have definitely 2 points that we know. X is negative 4, x is positive 4, but we also have 2 points here. Now, they don't have plots, they don't have dots, but we can estimate by just saying, okay, if the point here when y is 2, then let's say x is about 3/4, which is 0.75. On the other side, it's probably about negative 0.75. So just because we don't have points plotted here doesn't mean they're not still here, because this is all where y is 2. It's all the way across. And so sometimes that can be a little confusing, okay? But you just got to remember what you're looking for and how to locate it. Now, if I had to pick one topic out of 3.2 that seems to be the toughest, it's this next one. And for this next one, for what values of x is f of x greater than 1, what I want to know is, where is y bigger than 1? So what I normally do for that is, here is where y equals 1. Okay. So right here, this is where y is greater than 1, is above that line. above that line. Y is less than 1 below that line. So I'm looking for these areas of the graph where it is greater than 1. Now, the problem is, how do we give that answer? Okay, how do we give that answer? So what I'm going to do is I'm going to give intervals. So y is greater than 1 in these 3 locations. Okay, y is greater than 1 here, here, and here. Now, if I look at here, it's about in this area right here from 3 to 4 where y is greater than 1. It's also greater than 1 from about -3 to -4. And then it's also greater than 1 from -1 to +1. So, and this is estimation a lot of times because you can't tell whether it's equal to 1, whether it's greater than 1. It's an estimate. So, where is y greater than 1? Well, from x is -4 to x is -3. So from x is -4 to x is -3. And again, let's refer up here to right in this area, right where I've got it circled. Right there. Right there. -4 to -3. It's also from -1 to +1. So from x is -1 to x is +1. And then lastly, the other area is from 3 to 4. The other part we circled. So it's from x is 3 to x is 4. This is one way to identify it, because don't forget, we're asking about y values. So when we're ever answering questions about y values, we must give our answers using x values. The other way to list these is using your interval notation. And whether you use brackets or parentheses oftentimes depends upon whether it's greater than or equal to or greater than, but since we're estimating here, we can certainly use our brackets. So this is going to be one of the harder things to do, but always remember, when you're giving answers to intervals on a graph, when we're talking about parts of the graph, we've got to use our x values because we're asking about y, so our answer must be with x's. Okay? And we'll do more practice on this in class. So it's one of those topics. I know it's not going to click the first time possibly, but it's okay. Just always keep in mind to give x values for these answers. All right. So that's getting information from the picture on a graph. But we can also get information from the equation that would produce a graph. Because if we graph this right here, it would be a line. It would have a y-intercept of -1, slope of -2. So we could certainly graph it. But we can also answer questions about the graph without actually putting it on the coordinate plane. So my first question is this point 1, -2 on this graph? Well, the way I answer this is to find f of 1. If f of 1 equals -2, then it is. If f of 1 does not equal -2, then it's not. So f of 1 is -2 times 1 minus 1, which is -3. So the answer to this question is no. The point 1, -3 is on the graph. And remember, since it's a function, if x is 1, y is -3, it's not -2. So therefore, it's not on the graph. If x equals 2, what is f of x? Well, in this case, we want to find f of 2. So f of 2 is negative 2 times 2 minus 1, which is negative 5. So the point that's on the graph is 2, negative 5. So just always remember what's x and what's y. Part C, if f of x is 2, what is x? So in this case, y is 2. We want to find x. So then what we do is we say negative 2x minus 1 equals 2, because that's y. And then we solve for x. So we add 1 to both sides. Sorry about that. I didn't realize I was below the camera. So again, keep in mind y equals 2, find x. Set up your equation, negative 2x minus 1 is 2, and solve for x. Divide both sides by negative 2. So x is negative 3/2. So the point on the graph is negative 3/2 and 2. What are the intercepts? Okay, so first we want to find the y-intercept. So what I want to do is I want to let x be 0. So f of 0 is negative 1. So my y-intercept is 0, negative 1. To find my x-intercept, I let y equal 0. So anytime your y is 0, you set the equation equal to 0, solve for x. So I add 1 to both sides, divide by negative 2. So x is negative 1/2. So that's my x-intercept. Okay. So, as you're copying it down, list your points correctly. Know how to find your intercepts. Know what to do if you're given x. Know what to do if you're given y. Try to keep it straight. I know it's not always easy, but try to keep it straight. And that's pretty much what's in 3.2. Okay, so you're just going to be getting general information from graphs, points, intervals, things like that. Now, in 3.3, we will now look at what we call properties of functions. Okay. So first we want to look at if graphs are odd or even. So a function is odd if it is symmetric with respect to the origin. A function is even if it is symmetric with respect to the y-axis. Now there are examples in your book if you want to look at those. But what I want to talk about with an odd function and an even function is kind of when we talk about symmetry. An even function will look something like this, and it's symmetric with respect to the y-axis. So it could look something like this. So that means it's a mirror image on either side of the y-axis. An odd function is what we call symmetric about the origin. And it could look something like this. Okay, and in this case, my drawing's not real great, but in this case, if this point here, say for example, was 1, 1, this point over here would be -1, -1. They're kind of opposite signs. So when we look at odd or even functions, even is symmetric about the y, odd is symmetric about the origin. And again, we'll look at more examples of these in class. So that's a property, odd or even functions. Next is increasing and decreasing. Now I'm going to throw some arrows on here just because the graphing program doesn't draw them, and I think this helps get some confusion, because when we look at these intervals, even though this arrow is pointing downward, the graph is actually increasing because we always look as we go left to right along the graph. So it's actually increasing from here, it's decreasing to here, and then it's increasing from there. And this is the point -3, and this is +2. And we always want to identify intervals where the graph increases by looking left to right on the graph, and we have to give our answer using x values. So many times people want to give y values, because don't forget, we're looking at up and down. Up and down is the y. So you have to give me the x that tells me where it's going up and down. So in this interval here, it's increasing from -infinity to x is -3. And you can do interval notation, always parentheses for interval notation. Decreasing part is from x is -3 to x is 2. And again, we can use interval notation. I know you might think that's a point, and that's where people get confused, because these look like points, but they're not. They're intervals. So if you think you might get confused, then write it this way: from x is this to x is that. The other location where it's increasing is from x is 2 to +infinity, which again we can write as an interval. So just keep in mind, how you are writing these intervals, and that you must use x values. If there's one thing I can stress, please remember to use your x values. So if I was looking at this graph here, well, think about, even though the arrow's pointing upward, it's still decreasing here. Okay? It's increasing from here to here. It's decreasing from here to here, and then it's increasing from there to there. So you have your intervals. So once you divide up your intervals, then you just have to give your answer. So again, it's decreasing from -infinity to x is -3. And we can again write that using interval notation. It's increasing from x is -3 to x is 0. So again, this is not a point, it's an interval. Decreasing, x is 0 to x is 2. And then it's increasing, x is 2 to infinity, which as an interval looks like that. So you can give me your answers either way. You can either tell me the x is this to x is that, or you can use interval notation. But always remember, please try to remember to use x values. All right, so this is one of my examples I pulled out. It's, hopefully to kind of give you some concrete measurements other than just x's and y's or 2's or 3's. But we want to look at, where is this graph increasing, decreasing, and where it's constant. So you look at someone's weight, when you're starting at birth, your weight increases. You get to about 20 to 30. For most people, it might stay the same. Then all of a sudden, you gain them 50 pounds. Then you lose those 50 pounds. And then you stay constant. Not me. Mine goes up, down, up, down, up, down, up, down. But anyway, so, you've got increasing, constant, increasing, decreasing, and constant. So if I want to look at where it is increasing, okay, it's increasing. X is 0 to X is 20. It's also increasing from, looks like here, about X is 35 to X is 40. Now, remember, we can always write this using interval notation. Yeah, that's right. Now, it's decreasing from here to here. But we must look at the X value. So that's 40 to 50. So it took 10 years to lose 50 pounds. Only took 5 years to put on 50 pounds. So somebody's been eating way too much. So it's decreasing from X is 40 to X is 50. And again, you can do your interval notation. And it's constant from 20 to 30. Right there, it's constant. And again, we can use our interval notation. And it's also constant from X is 50 to death. So we'll just say to infinity for that one. Okay, so, just try to remember to give your X values. These are not points, they're intervals. These are all X's right here. And I know that's confusing because we always look at X, Y, but just know that if it's an interval, it's between two X's. All right, so now we're going to look at what we call the local maximum and local minimum values of a function. So when we talk about local, think about local. If I just said maximum, that's just the highest or lowest point on the graph. But when we talk about the local maximum, it's the highest point on any interval. And it occurs at some X. And then we also supply the Y. The local minimum is the lowest point on an interval. So your intervals are from little humps. It's where the graph changes direction. It's where it goes from decreasing to increasing or increasing to decreasing. So right here, we have a local minimum. Right here, we have a local minimum. And right here, we have a local maximum. Now, this minimum here, it occurs at X equals -2 and the minimum value is Y equals -152. So we always want to give it's just like giving the point, really, is what you're doing. You're just giving the point. X is -2, Y is -152, but they're going to ask it for it differently in the book, or the way they word it sometimes is confusing. And the next example, I'll kind of show you what we mean, but I'm perfectly fine for you just telling me X is this, Y is that. Okay. The other minimum occurs at X is 3 and Y is -27. That's what the actual minimum value is. The local maximum occurs at X is 1 and Y is 37. Okay, so you're just pretty much locating points. You're locating points. So example 3 is kind of where I'm going to show you how they word it in the book. So if you look at the graph here at example 3, you do have a local minimum here and here, and a local maximum there. So part A, at what numbers does F have a local maximum? So at X is 1 is the local maximum, and then what are they? Y is 2. So that's how they're going to ask it for you in the book. Okay? But again, you can just tell me X is 1, Y is 2. Part C, at what numbers, if any, does F have a local minimum? Well, it has them at X is -1 and X is +3. What are they? Y is +1 and Y is 0. Okay, so hopefully you're getting the hang of this. At what number is the X's? What are they? What are the actual minimum or maxima? They are actually talking about the highest, lowest point. Now, where is F increasing? Well, it's increasing from here to here and from here to the infinity. So again, remember, you're looking at your X values. So from X is -1 to X is +1. Using an interval, we can do that. It's not a point, it's an interval. And I know it's going to confuse you because that same point there looks like that same interval. So write it like this. Write it like this if you're worried about you're going to mess it up. Okay, write it like this. The other place it's increasing is from X is 3 to infinity. And it can be written like that. Okay. Where is it decreasing? Where is it decreasing? Again, it's decreasing from here to here. Even though that arrow's pointing up, it's still decreasing from here to here. Decreasing from here to here. So it's decreasing -infinity to X is -1. It's also decreasing from X is 1 to X is 3. Again, we can use our interval notation to give those answers. So I guess if I was to point out the trouble areas, it's making sure to use your X's and not your Y's for increasing and decreasing. Understanding that if you're going to use interval notation, that's not a point, and that's easy to get confused there. And making sure you don't look at the arrows. You look at what's the graph doing as you move from left to right. As I move from left to right, this graph is going down. Okay, so we will do more practice on these in class. That's all I have. I know that was a long one, but it's 2 sections. So hopefully things are making sense to you, and we will see you in class.